Okay, folks, welcome back to History 393, Digital History. We're going to talk today a little bit about JavaScript. It's a big step up, actually, from HTML and CSS. And good morning. This is about my 7th time trying to record this, and hopefully it goes well. Okay, so we've spent some time already learning HTML and CSS. They have both been really important, actually. Um, Neither one of them is a full-fledged programming language in the way that JavaScript is. So we're really making a big change here. So JavaScript's way more powerful and as a result more complex correspondingly. Uh, as you remember, HTML is responsible for the structure of a web page, CSS is responsible for the presentation layer, and JavaScript is responsible for most of the dynamic transformation of web pages and most dynamic transformation that happens in a lot of the apps that you use on your phone. We will be learning a lot, actually moving kind of quickly and skipping over computer science-y foundations of computer languages. But so in some ways we're moving fast, but we also try to proceed with baby steps as much as possible. What I would recommend when you watch this video is that you watch a little bit and then pause and do some of the work. Remember that these lectures are available online, the lecture slides, and the code examples in this lecture are live. So you can just follow along in the presentation and enter code directly into the code boxes and see what they do. There are other ways to enter code, and we'll talk about that in a second. Yeah, so even though we're not going to talk about computer science, we might as well just spend a moment talking about what computer languages do, like what makes them powerful. And I kind of think about them in terms of these sort of big ideas. Formalization and abstraction sort of go together, and maybe we should talk about formalization first. Uh, we speak in our ordinary language, we converse in an informal language, and informal languages are tremendously rich, and they are great for human beings, and they're terrible for computers, which are not cognizing entities. They do not have, you know, they they are not equipped to infer meaning. Instead, they are useful at following what are essentially mathematical rules for manipulating information. So in order to make computers work, we have to write in a formal language in which every instruction is unambiguous and in a determinative way uh, uh, invokes a set of operations that can be reduced to switching gates on and off in the silicon basis of a computer chip. So formalizing languages is powerful and also reduces some of the richness of ordinary speech, and so it also has limitations. But when we formalize, we are required to perform a second activity, which is abstraction. We have to uh, reduce the entities that we are interested in examining to a set of abstract properties, which can then be rendered mathematical and and manipulated directly by the computer. So, if we're interested in historical figures or historical events or literary texts, we have to decide what properties of those entities we're interested in, and turn them into abstract quantities, whether those are numbers or strings of characters or whatever, and our work is going to take place on those abstract quantities. Again, extremely powerful and also a reduction in richness. One of the really amazing features of performing this kind of abstraction is that it allows us to do something that computers are excellent at and that we are bad at, and that is repeating things over and over again without mistakes. So once or that is to say, any mistakes are either programmer error or an error in the abstraction itself or a limitation of the abstraction. So we'll see some of those limitations even in our very simple examples today. Yeah, so those are three big programming ideas that it's important to kind of, have in the back of your head, have your eye on a little bit while you're learning this stuff. And the final big idea that I think is really important is to remember that in computer programming, laziness is a virtue. So you want to do as little as possible, and you want the computer to do as much as possible. So when you're programming, you have to mobilize your inner slacker. On the one hand, you're going to be working really hard, and on the other hand, you're going to be trying to get someone else or something else to do the work for you. Assignment 2, which you have not yet received, will require these things of you. It will require a grasp of basic JavaScript syntax in the way that you also have to learn basic HTML and CSS syntax for assignment 1. You will have to understand what a variable is, and you'll have to be familiar with some basic variable types. You'll have to know what a function is and how to define one. You'll have to know how to repeat actions in loops or iteration, and you'll have to understand branching logic and conditionals. So we're going to talk about some of these things today, but not all of them. And then finally, I put this in its own box, although it actually is encompassed by some of the things I say above. There is a special type of variable called an object in JavaScript, and you're going to have to just begin to understand some of the complexities of how an object works and why you would use one and why you wouldn't use one. Okay, so when we run HTML and CSS, we run it in the browser. So what we do is we send the files to the browser, and then the browser creates an environment in which the HTML and CSS combine to display something to us. So they do work, HTML and CSS, in the context of a special environment. It's a little bit, it feels obvious and easy to us because we use browsers so much. Now, JavaScript will run in general in a browser environment, but we will not directly see the results of JavaScript, especially in the kind of work that we're doing right now. And so what we need to do is enter a more accessible environment in which the low-level functioning of JavaScript is apparent. And we can do that in several ways. I'm going to show you some of those ways, not all of them, but I'm going to show you some of those ways right now. The browser provides a special environment called a console in which JavaScript can be run directly. And let's maybe check that out right now. Oops. Here we have a regular browser window. I'm going to go to the DevTools in the kind of slow way over here, Web Developer, and open the console. This is me in Firefox. It will look a little bit different in Chrome. Often, by default, it is docked to the right side of the window. I personally like it better on the bottom, and you can move it around by dragging it. So we'll see that there are here. Let's make this big. There are two sort of panes in the console. This one, which shows warnings and errors in the loading of the page, so that's just generated by the interaction of the browser with the web page. And over here, I'm going to clear that output right now so we can focus on what I'm doing. Over here is a little area in which I can type code and then run it directly. So I'll do the classic JavaScript hello world, which is to type console.log. That means log to the console or print to the console. And this is the classic way to do it. So I'll type some JavaScript code, and then I can press this run button, or I can just press Control Enter, and it will perform the operation that I'm asking to. And in this case, it will print hello world. You can see that this is just one pane in the DevTools. We're familiar with the inspector from before, and this is the console. Okay, and then another way that we can run JavaScript is in the terminal. So you can open the terminal window if you're in Mac, or there's I git bash in Windows, and I can enter the command node. You remember installing node before, and that will drop me into a console environment, and I can issue the same command. And it will give me the same output. So you can fool around in the terminal, in the console if you like, and you will remember that there is also a built-in terminal in VS Code, and we can run the same command there. Ta-da! Okay, so that's enough for today, and I'll show you this cool thing in VS Code called Quokka later on, which is an extension that will kind of continually run your code in a console environment and provide you with certain kinds of output, and that's pretty cool, actually. Okay. So now let's begin to talk a little bit about how JavaScript works. And the first thing we want to understand is what a variable is. Some of you will remember, variables from doing algebra in high school, and algebra and other maybe more advanced mathematics. Our name variable comes from math, so computer science began as a branch of mathematics in a way. There are at least two ways that we can think about what a variable is, and the first is probably a little bit more closer to being technically correct, and the second might be easier to understand. So one way to think about a variable is that a variable is a name for a memory location, a spot in computer memory that stores information that can be used later. And it stores that information in specific ways that depend on the variable type. So one type of variable will store information in one way, and another will store in another way, and the amount of memory that is reserved for that variable value is different with different variable types. But we're not thinking about what's happening inside the computer behind the scenes. At least we're not doing so most of the time. And that way we really are different from computer science students. And that's good, because JavaScript is a particularly lousy language for learning about those low-level fundamentals. So another way to think about a variable is as a box into which you put information that you will want to get later, in much the same way that you might have an object in your house that you put into some kind of container in order to be able to use it later, or the way that you might have boxes, little plastic Tupperware containers in your lunchbox, into which you put the food that you will want to retrieve at a later date. So we see here 3 boxes, and in each box there is a value. These are different kinds of values. In one, there's what we call a string, a collection of characters strung together that make up the name Bob, and the other is the simple value, which is sometimes thought of as an on-off value in computer programming, the value true. And in the third, we have a number, 35. So in order to create variables, to make the computer, to make the JavaScript aware of the variables, we have to declare the variables and assign a value. And there are three ways to do this in JavaScript. There's the old way, which is with the keyword var for variable. And you can, in general, I tend to declare and assign at the same time. You can just declare and not give it a value, but let's not think about that. So we try to avoid this this way of declaring variables now because it has certain kind of limitations that screw up people's code pretty easily. But sometimes I'll forget and use it, so you might see it scattered through the code in the assignments, and you will definitely see it on the web when you're scavenging code, which we'll do later in the semester. So you just want to be aware that that's what var is. Instead of var, we will use two other ways of declaring variables. Const for variables that don't vary, that never change, so which are better understood as constants, and let for variables that do change. So we see that the declaration and the assignment are taking place in the same line, but we can reassign, we can assign new values to the variables. So for instance, first thing I'll do is get the sort of console window here to show us the value of often changes, which is 0. But I can assign with the equal sign a new value. And we can see that often changes is 15. I can also change the type of the variable when I assign a variable. So you'll notice that something interesting has happened to the display of the string there. We can talk about that later. So yeah, now I can do that with variables that are declared with let, and if I try to do that with a constant, I will instead get I should get an error. I don't know why I'm not getting an error right now. You will get an error in your code if you try to redeclare a constant, or reassign a constant rather. Okay, so you feel free to play around with this code a little bit and stop the video maybe if you want to. It's important, we work with textual information, the textual display of information, and so we can just begin to get a taste for this by working a little bit with the manipulation of text. And we can see here I've declared two variables, first and last, which are my first and last names, Matt and Price, and now I'm logging those names to the console, and we see we get a new string of characters, which has a little problem, which is that they are missing a space. So I will do that to what is going on? There's something frozen in my little thing. If you run into problems with the code, just reload the page, and the code will reset to the original value. Okay, so you can see that we can perform these manipulations on strings using the plus sign, which means squish strings together. Now, I just want to show you. So stop and give it a try with your own name. I want to show you some of the power and also a little bit perils of working with different variable types in JavaScript. JavaScript is what is called a weakly typed or dynamic typed language, and what that means is that variables, you can't tell by looking at them what type of variable is going to be in JavaScript. And one of the consequences of that is that we might sometimes have kind of unexpected effects because for instance, the plus sign means different things when you're working with two numbers than it does when you're working with a string and a number or something else. So, for instance, I have three variables here: m, n, and s. N and m are numbers 1 and 2, and s is a string hello there with a space after it. And if I log to the console the value of m plus n, then JavaScript will kind of be smart and add the numbers together. If I do it with a string, then JavaScript will also kind of be smart and squish the string representations of these different variables together. But if I try to add the two numbers together, then we'll see what I get. Hello there, 1, 2, and that might be what I wanted, but probably it's not. In order to get the numerical calculation to take place, I'm going to group the variables together. And you see what I just did. That's a lot like using parentheses in math that you'll remember from high school. Okay, so that's what variables are. You're going to have to be familiar with these variables types in your work in JavaScript, and this might be a good time to stop and look them up a little bit on the Mozilla Developer Network web pages. So some variable types are numbers, which can be integers or decimal values. Strings, which are collections of characters that have been strung together. Booleans, which can only take the value true or false, whereas strings are defined inside quotes, singular or double quotes, or backticks. Booleans are, you write out the word true without, or false without quotation marks. You'll remember doing this from JSON in the very first assignment. Arrays are lists of items, and we're about to talk about them, and objects are more complex, and we'll talk about those in a later lecture. Okay, so let's talk a little bit about making lists. We're going to work a lot with lists here and also in the assignment. And we see here the variable declaration and assignment. In which we start with the keyword let, which says I'm about to declare a variable. We get the name, historians, and then we have the assignment, which is the equal sign, and then the construction of the array. So you see here we have square brackets, which say I am a list, I am an array, and then the elements of the array, which are separated by commas, and in this case, all the elements of the array are variables, are strings, and they're enclosed in quotations. And here we'll be able to see the value of the array, and you can see that not all the elements of the array have to be of the same type. So I can add Boolean, and I can even add an array as an element of the array, so we can have nested arrays. All right, check that out, fool around with it if you like. Here's another way to construct an array. So in the previous example, we constructed the array by listing off all its elements. Here we can add elements one at a time. So we begin by defining an empty array, and then using the command push. So we have the variable name a dot push. and then add the elements one at a time. And we can see that having pushed those elements, we get an array with 3 elements in it, and add something to the end of an array. So Edward Gibbon, then Edward Said, then John Scott. We can take something off an array by popping it off the array, and that pops the last item off the array. And it also returns that last item as a return value, and so that's the returns A. And then finally, I wanted to just show you how you access the elements of the array, and that's with the name of the variable followed immediately by a set of square brackets with a number in between. And in this case, we have the number 1. In JavaScript, as in almost all programming languages, arrays are 0 indexed, so that can be a little bit confusing. The first element of an array is numbered 0, and the second element of the array is numbered 1. And so when we put in A sub 1, we get back Edward Said. In order to retrieve Edward Gibbon, we're going to have to put in the 0th element of the array. Okay, so fool around with that a little bit. And here we are with an array of numbers, and we can see something interesting here. The array is a set of years in which wars took place: 1776, 1792, 1812, 1861, 1870, 1914, 1939, 1994. Maybe you know all of these dates, and maybe you only know some of them. And what we're going to do is just quickly log to the console an operation on the elements of the array. So what we're going to do is try to log the time between the First and Second World Wars, and we say it was war date sub 6 minus war date sub 5, and that gets evaluated to 25. So we say the time between the First and Second World Wars was 25. Look this over carefully yourself, maybe make some changes, and then ask yourself, is there something a little bit wrong with the way the sentence is phrased, and does that tell us a little bit about how we have to be careful when we work with numbers in JavaScript? Okay, so that's our variables part, and now it's time for us to talk a little bit about iteration, about repetition, and we're going to be introduced to several syntaxes for writing loops that iterate, in this case, over arrays. So allow us to take the elements of an array and do some repetitive action with those elements. So in some ways, the easiest way, not the easiest, but the most kind of comprehensive style of writing a loop is a while loop, and we can see with a while loop the individual components of an iterative process, and it's useful here to just check them out. I actually almost never write while loops in JavaScript, although a lot of people do actually. But it's still, I think, useful for helping you to understand how looping works. So we have this, let's say, this while construction. So we have while, and then some what's called a test in between a set of regular parentheses, and then after those parentheses is an open curly brace with a set of instructions, and at the end is a closed curly brace. So what that says is, while the condition or test is true, repeat these instructions. But in order to set up the while loop in general, what we're going to do is first assign an initial value to what's called a counter variable. By convention, we usually name it I, unless that is not available to us for another reason. So we're going to declare a variable I. We're going to then use that variable in the test. So the first time we go through the loop, I is equal to 0, and that is, in this case, 0 is smaller than the length of the variable of the array historians, which is 4. It has 4 elements in it. And then we're going to refer to the ith element of the array. So I is 0, we get the 0th element of the array, which is Edward Gibbon. And then, this is really crucial, we increment the value. This is the same thing as writing I equals I plus 1. So we set the value of I to 1 greater than it is already set to. And then we go through the loop again. So the first time I is 0, but now when we go through the loop, I is 1, still less than historians.length, and we get the 1th element of the array, which is Leopold von Ranke, and we print out Leopold von Ranke was a historian. We go to do it again, we get Edward Said, and the last time we get Joan Scott, and so we get a total of 4. Then that time, by the time we're done, I is set equal to 4. 4 is not less than the length of historians. In fact, 4 is equal to the length of historians, and so we no longer run this code. We're done with this part of our code, and we move on to the next instruction. So yeah, remembering that we have the initial value, the test or condition, and then the change in the condition, and all of those are required. If I were to take out that condition, and you can test this at home if you want, we would end up with an infinite loop, and your browser would stall and maybe crash. So I'm not going to do that here because that slows us down. So in a while loop, it's you can see all the pieces of the iterative process, maybe a little bit easier because they're separated. It tends to be easier in a while loop to forget to increment the condition and then end up with a situation that crashes your browser. So that's a hazard. Here we have a very similar process. It's also iterative, but it uses the for syntax, and for loops work in a very similar way. Sorry, I'm having trouble highlighting. We have the keyword for, which is like while, but then we have inside the parentheses the declaration of the initial value of the counter variable, the condition test, which is like it was before in while, and then also the increment of the thing that we do each time we go through the loop. In this case, we've written I++, which is the same thing as I plus equals 1. It's just a kind of idiomatic way of saying increment. You can also say minus minus to decrement a value. We'll see that later. Yeah, and we can see that it does the same work. So while loops and for loops do the same work. They're just written a little bit differently, and for loops often are a little bit more kind of intuitive, and especially when you're working with arrays, you can kind of hear that you're going to do something for each element of the array. Okay, so stop, fool around, and now we're going to look at other ways of writing for loops. These are new-ish, not new, but these were introduced into JavaScript a little bit later, and they can be easier to write. They work the same way as other for loops, but they hide some of the syntax that we just learned. It's really important to remember that syntax is buried in these loops, and sometimes that can help you kind of identify the problems with your own code. So these are very, very similar. They are in and of loops. So for I in historians, and that really should, yeah, it's better to always write that let. And for H of historians. So they do almost the same thing, but they work slightly different ways. In the in syntax, the I, each time you loop through the array, will be assigned a numerical value that refers to the position in the array. So it starts with 0 and goes to 3. And we'll have to use that variable I in the same way that we would in a regular for loop. Historians sub I, get the ith element of historians. The of syntax is almost the same, but it assigns the variable, in this case we're calling it h, and in order to kind of help us think about how it's different. I mean, we could also call it, might be a little, the loop variable, the variable declared in the in the loop condition, will refer not to the position in the array, but to the actual element itself. So we'll go out and grab the element and be set to the value of that, directly to the value of that element. Yeah, they can be super convenient. You should read about them in MDN. Okay, so that's all our loop stuff. You might want to pause and just fool around with them a little bit more so that you feel like, yes, I understand this and I can make sense of it. And we're going to move on now to talk about conditional statements or branching logic, in which the computer takes certain actions depending on the circumstances, the condition that we set to it. So here we have our while loop from the very first looping example. And we notice, though, that instead of just doing console.log, we wrap that console.log in another set of curly brackets, and you'll begin to see when you're working with JavaScript, there will often be many, many nested sets of curly brackets delimiting the scope of like a while loop or of an if statement. So it's constructed in a similar way. We have the keyword if, and then we have these parentheses. And this time, though, the parentheses surround what is called just the condition or the test. If this test is true, or sometimes in JavaScript we say truthy, then we'll execute what's between the braces, and if it's not true, we won't execute it. And so what we're asking here is historians sub I, the ith element of historians, equal to Joan Scott? The first 3 times we go through it, it's not, and so we skip this instruction. The last time it is, and so we perform the instruction. And so we only get 1 line of output from this code, which is Joan Scott is my favorite. So one thing to note is the presence of a whole bunch of equal signs run together. In this case, 3. We can use 2 or 3, but we try to always use 3. So this is really different from a single equal sign, and one of the very common mistakes is to kind of forget in the haste of writing the difference between them. And I have to say, I still make this mistake occasionally. So we can see that when we have a single equal sign, like up here in the variable declaration or in the variable assignment statements that I typed earlier on in the lecture, then what we're doing is assigning or setting a variable, which is on the left side of the equal sign, to a value which is on the right side of the equal sign. So the equal sign is not symmetrical. We have a variable always on the left and a value always on the right. The triple equal sign is symmetrical, and it's much more like mathematical equality. It says it's asking the question, is the left side of the equation equal to the right side of the equation? And if it is, then it returns the value true, and if not, it returns the value false. So as we go through this loop, we can kind of rewrite this as if false, do this, so we don't do it. If false, do this, so we don't do that. If false, do this, so we don't do it. And finally, if true, do this. And so we do it in the last instance. So I can actually rewrite this. Oops. And then, so then the test is always true. And then the test is never true. That would be kind of a stupid condition. This is a better condition that will actually do some branching. Okay, so that's your basic if loop. The kind of extension of if loops in JavaScript, as in many other languages, in else statements. So sometimes you want to do one thing under one set of circumstances and something else under a set of another set of circumstances. And in this case, we're going to print one thing for Joan Scott and another thing for our other historians. So this evaluates in our first three cases to false, and so we skip this and instead do this. And so what we get is Edward Gibbon meh, Leopold von Ranke meh, Edward Said meh, and Joan Scott is my favorite. Okay. All right. Okay, yeah. So that's an introduction to some of the main syntactical elements of JavaScript and some of the main features. There's a ton more to learn, but I'm going to stop here for now and talk about functions in a separate lecture that you can watch another time. Thank you for joining us, and I will see you in lecture in not that long.